In today's video, we'll be going through the process of how to graph polar equations. Well, there are different types of polar curves, those being Limassons, rose curves, as well as circles. Well, now, let's look at the first one, which were Limassons. In Limassons, there are 4 different types, those being Limason with an inner loop, a cardioid Limason, also known as a heart-shaped Limason, as well as a dimpled Limason and a convex Limason. Well, to start off, let's look at the basic equation for a Limason. The basic equation for Limason is R equals A plus or minus B cosine of theta, or R equals A plus or minus B sine of theta. Also, A is going to be greater than 0, as well as B is going to be greater than 0. Now, you might be asking, what does A and B represent? Well, A plus B equals the entire length of the Limason, and when looking for the length of your intersection, you have to do B minus A. And A minus B equals the length of the intersection. Let's go ahead and look at a Limason with an inner loop. A Limason with an inner loop looks something like this, where you can see that we have a Limason and then we have a circular inner loop right here. And when you have a Limason with an inner loop, A over B, the quotient of that is going to be less than 1. That's how you know you have a Limason. Let's go ahead and do some practice with that. So now let's go ahead and look at the cardioid Limason. For a cardioid Limason, you can see it looks like a heart. And for a cardioid Limason, A over B, the quotient of that equals 1. So it could be the same number. Next, we have a dimpled Limason, where 1 is less than the quotient of A over B, and that is less than 2. Well, we're going to say that our inner loop goes to 1, and our total Limason goes to 5. So we need some 2 numbers which add up to get 5, so plus to get 5, and subtract to get 1. So we know it's R equals cosine because its axis of symmetry is on the x-axis. This means that we have to find 2 numbers that add up to 5, and when subtracted, they give you your length of the intersection. So 2 numbers that add up to 5, let's just do 2 plus 3 equals 5, right? And we're going to say A is our 2 and B is our 3. And we said that B minus A equals the length of intersection. And the length of our intersection is 1 because we're starting at the origin. So we need something minus something equals 1. But 3 minus 2 equals 1. So that means our A value is 2 and our B value is 3. So we can do 2 plus 3 cosine of theta. And when you graph this, you should get a Limason with an inner loop that looks something like that. Now let's go ahead and do a practice problem with our cardioid Limason. And for a cardioid Limason, it's going to always start at the origin. Well, the quotient of A and B equals 1. Well, we can see that it's going to be the same number. And we know that if its axis of symmetry is the x-axis, it's going to be a cosine. And we can see that this one has an axis of symmetry of the x-axis. So meaning that this is going to be a cosine Limason. So we have R equals something plus or minus something cosine of theta. And now we need to find A and B. Well, we know A and B are going to be the same numbers, so let's just say that this is going to be 6. Well, a number subtracted by itself is going to be 0, so it's always going to be starting at the origin. So let's just say 2 numbers that add up to 6. We can say 3 and 3, meaning that R equals 3 plus 3 cosine of theta. And if you're wondering when it would be minus, well, right now we can see it's facing to the right. If it were to be negative, so it would be R equals 3 minus 3 cosine theta, this graph would be flipped 180 degrees, and it would be facing to the left. But in this scenario, it's facing to the right. That's why we have a positive B value. So let's go ahead and look at the next type of polar curve, that being a rose curve. Well, a rose curve looks something like this. You can see it looks like petals, and there are certain rules you have to follow when dealing with rose curves. Well, first off, the base equation for a rose curve is R equals A cosine n times theta, as well as R equals A sine n times theta. And you might be wondering what the n is. Well, the n is going to represent the number of petals in some way. Here are the rules that I was talking about. The first rule is that when n is an even number, 2 times n equals your number of petals. And the second rule is when n is an odd number, n equals your number of petals. You can think about n equaling half your petals. And in this scenario, A is going to be representing the length of your petal, and n is going to be representing your number of petals, and you must refer to the rules when using the n value. So now let's go ahead and do a practice problem for this type of polar curve. Well, we can see that we have a rose curve right here, and it has a petal length of 4, and we can see that the axis of symmetry is this x-axis. Again, it's going to have the same type of rule, where if its axis of symmetry is the x-axis, it's going to be cosine, and if the axis of symmetry is the y-axis, it's going to be sine. So now what we need to do is right that r, well, the equation's right here, but let's see how we got it. So we know r equals something times cosine something times theta. Well, we remember we said that when n is odd, n equals the number of petals. Well, we have 1, 2, 3 petals. Well, we know n equals 3 now, because we have an odd number of petals, n equals our odd number of petals. So now we need to find the length of each petal. We said the length of each petal is 4, so we have 4 here. We start at the origin, so we have an r value of 4. The equation for this is r equals 4 cosine of 3 theta. Now let's go ahead and do one more practice problem for rose curves. This one you can see that the axis of symmetry is the y-axis, meaning it's going to be a sine graph. So we have r equals something times sine of something times theta. Well, now what we need to do for this type of problem is see how many petals we have. Well, we have 4 petals. 1, 2, 3, 4. And if we refer back to our rules, when n is even, we have 2n equals the number of petals. So if we divide our number of petals by 2, we'll get n. Well, we know n equals 4 over 2. 4 over 2 is obviously just 2, so we know n equals 2 theta. This is our n value. Now we need to find the length of each petal, which is our a value, which goes here. Well, we said that we can see that from our graph, the length of each petal is about 2. This would be negative 2. And so we have a length of 2. And that is going to be our equation for the second rose curve. Now let's go ahead and do circles, which is the final type of rose curve that we're going to be covering in this video. And the equation for a circle is going to be r equals a cosine of theta and r equals a sine of theta. In the circle type of polar equation, a equals the diameter of the circle. And let's look at this first one. Well, we can see in this first one, we have a diameter of 5. We're going 5 to the right, 5 to the left, and 5 up. So we have a diameter of 5. We said a is our 5, and the basic equation was r equals a sine or cosine of theta. Well, the axis of symmetry is this y-axis, so we're going to say this is a sine value. So we have r equals our diameter, which is 5. R equals 5 sine of theta, and that's our equation. That was really simple. Now let's go ahead and do one more practice problem for circles. This one we can also see that we have a diameter of 5. Well, for this type of circle where it's centered around the origin, the equation is just r equals a again still being your diameter. So now we can see that the diameter is 5, so it's just r equals 5. And remember, this is only when the circle is going to be centered around your origin. Well, I hope this video helped, and if you believe it did, please consider to like and subscribe. I'd greatly appreciate it. We do have an Instagram for future video updates. If you do hit the bell notification icon, you'll be updated on all videos. I'd greatly appreciate a like on this video, and please do consider to subscribe. Thank you.